Mathematics. Today we are looking at the review of Physics Paper 4 Extended, February-March 2023. Total duration is 1 hour 15 minutes. And then the question 1 of this paper is a question that has to do with vector addition, scale drawing, and vector quantity. So let's look at it. I'm going to take it question by question. You are expected to answer all questions and then take notes. In this particular paper, they expect you to use the acceleration due to gravity as 9.8 meter per second square and not the conventional 10 that we normally use. So it says you are advised to always read the instruction. The total mark for paper 4 is 80 marks. A boat crosses a river. The boat points at right angle to the river bank as it travels at the speed of 3.5 meters per second relative to the water. A river current acts at right angle to the direction the boat points. The river current has a speed of 2.5 meters per second. By drawing a scale diagram or by calculation, determine the speed and direction of the boat relative to the river bank. But in this particular method, we are going to use the scale drawing. You can use calculation, it's actually easier. Then find the speed. Speed is a scalar quantity and velocity is a vector quantity. State one other scalar quantity and one other vector quantity. So that gives you the total 6 marks for this question. So let's go identify the river bank. So this is the river bank. So the water is flowing like the river bank. So the water is flowing like this. So this is the other end. So the boat is going to leave from this bottom and cross over to this point. Then the water is flowing in this direction as the laser beam is moving. So let's assume the water is flowing from the left to the right. And so we take our starting point. The boat is going to move. The boat point at right angle and cross over the river. So the boat is going to start. And then we are going to use the scale of 2 cm to 1 meter per second. So if I draw the distance of 2 cm, they represent the speed of 1 meter per second. So since the speed of the boat is 3.5, so that 3.5 multiplied by 2, that will give me 7 cm. So we have that 7 cm. So the total length is 7 cm. So with that total length of 7 cm, so with the ruler, we can measure 7 cm. So let's do that. 7 cm there. Remove the ruler. So that is the velocity of the boat. Now let's get the velocity of the river. You say the river moves with the speed. River current at right angle direction to the direction the boat points. So at right angle like this, it can either be this way or this way. The question did not specify it, so let's assume that the water is flowing from left to right. But if you now assume that the water is flowing from right to left, so it can go either way. So it was not deliberate. So what is going to be the scale, the vector that will represent the current of the water? So 2 times that will give us 5. So the length 5. So we draw the length of 5. So let's remove the ruler. So the line that connects this will give us the resultant, which is the relative velocity of the boat with respect to the river. So if you do that, we have it. So now we are expected to, what is the speed? This length with a ruler. So if you measure that end, so that gives us about 8.6. So divide it with your scale, that gives the speed of 4.3 meters per second. So let's remove the ruler. So the next thing we need to know, what is the direction of the relative velocity relative to the river bank, that is to this point. So what is the direction? So with protractor we can measure that. So if you look at that, that is about 50. So this is 50, 51, 52, 53, 54. So the angle is about 54.5. So that gives about 54.5 degrees downstream. So that is it. So with this, we have finished this question here. So let's go. Speed is a scalar quantity and velocity is a vector quantity. State one other scalar quantity and one other vector quantity. So scalar quantity, mass, time, and volume. Then vector quantity, acceleration, momentum, and force. So with that, we have finished this question. Let's go to question 3. Question 3 shows a ship loaded with container. So this is the ship loaded with container. The ship is made up of steel. The density of steel is 7,800 kilogram per meter cube. Explain why the boat floats on water. So for 2 mark. The container with the greatest mass are loaded near the bottom of the ship. State and explain the effect on the stability of the ship of loading the container this way. A crane lifts a container 48 meters vertically upwards. The mass of the container is 30,000 kg. Calculate the energy transferred to the gravitational potential energy stored in the container. The ship is made up of steel. The density of the steel is this. Explain why the ship floats on water. Now, the first point here you need to know, for floating to take place, an object can only float if the density of that object is lesser than the density of the liquid on which it is floating. So this ship can only float on water if the density of the ship is less than the density of the water on which it is floating. So why is it that a ship which is made up of steel can float on water? Is because this steel is not total steel. If it were to be a total steel, if I drop a rod on water, there is no way the rod can float. But a ship is floating because the middle of the ship is occupied by air. So the total mass, the total volume of this ship is the volume of the air plus the volume of the steel metal. So you can now calculate the average density, which is going to be the density of the air plus the density of the steel. So when you take the average of the volume of the gas and the solid, they do not produce a density that is lower than the density of the liquid. So the average density of the ship is less than the density of water. That is why ship floats on water. So ship is not a solid steel. There are air spaces in the ship. So the average density of ship is less than 1,000 kilogram per meter cube, which is the density of water. So of the ship. State and explain this reason is to increase the stability, because the lower the center of gravity, the higher the stability. So condition for stability, the center of gravity is lower, and then so the ship is more stable. It's as simple as that. So you have your 2 answer mark there. A crane lifts a container 45 meters high. So calculate the gravitational potential energy. So the gravitational potential energy is the mass of the container multiplied by the strength of gravity, which is 9.8, multiplied by the height through which the container was lifted by the. So this will be, what is the mass? 30,000. So 30,000 multiplied by that, so that gives about 14,112,000 Newton meter joule. So that's approximately 1.4 times 10 raised power 7 joule. One form of energy to another. So if you state this principle of conservation, you have your 2 marks. A wind turbine has a maximum output power of 1.8 million watts. The turbine operates at a maximum power of 4 hours. Now, define the unit kilowatt hour. What is kilowatt hour? This is the energy transferred in 1 hour at the rate of 1 kilowatt. So this is just a critical thinking question. 1 kilowatt hour is the energy transferred in 1 hour at the rate of 1 kilowatt. Now, what it means is that for every 1 hour, the energy that will be transferred, the energy will be transferred at the rate of 1,000 watts. That is the energy that will be used up every 1 hour. So energy produced is equal to power multiplied by time. So what is the power? Which is 1.8 million watts. So that will now be expressed it in kilowatts, which is 1,800 kilowatts. Then time 4 hours. Time 4 hours. So multiply it because you expected to calculate the energy in kilowatt hour. So just convert your power to kilowatts and multiply by the time in hour. So if you have that, that will give me 7,200 kilowatt hour. Radiation from the sun is the main source of energy from most of our energy sources. State 2 energy sources that are not due to radiation from the sun. We have about 3 of them. You have tidal energy, that is from the flow of water. Then we have geothermal. This one comes from the moon. Geothermal from hot rock. Then nuclear from atomic particle. So none of this one have to do with sun. So we have the total mark here for this question, 7 mark. Let's go to the next question. Metal pan on an electric hot plate. The pan contains 200 cm cube of water. So the amount of water poured into this. Then you have the hot plate for heating it. Now the pan is heated. The temperature of the water in the pan increases. Thermal energy is transferred through metal by conduction. So we are going to look at the method of heat transfer by conduction. State and explain 2 ways that thermal energy is conducted in a metal. So what they are interested here is explain in terms of molecular theory how heat thermal energy is transferred through the method of conduction. So what is it? Free electrons and particles vibrate. So the 2 way is what? Through the movement of free electron and then particle vibration. So these are the 2 ways responsible for the transfer of energy. Now, what does free electron? When free electron moves through the metal, they collide with distant particle as the electron carry energy through the metal. So this is one way. And then as they carry energy, then the next one is the vibration process. The particle lattice vibration transfer energy to neighboring particle when they make contact with each other. So the particle vibrate and cause nearby particle to vibrate. So you see the conduction process. Then the vibrating particle collide with particle transferring energy. So these are the how you can explain conduction using the molecular atomic model. So as gas, explain in terms of forces and distance between particles why the gas occupy much greater volume than it does in a liquid. Okay, so if you look at this, water changes from to steam. So that process is called, because of boiling, that is a what? Vaporization. And it takes place at the boiling point at a constant temperature. Explain vaporization in terms of forces. So the first thing we are going to look at, you look at the distance between the particles of water and then the particle of gas. Particles of gas are far apart, so the red one. Particles of water are closer apart. And then the force of attraction holding this particle together is stronger. So that's how you see, for liquid is stronger, so the particle, the force to break away from this liquid, you need more energy. But for gas, because the force of attraction between them is weaker compared to the force of attraction between liquid, the water particle, then the steam, the particle in steam, has less force of attraction between them. So let's see. So the attractive force between particle in liquid is much greater than those in gas. Then particle in gas are much further apart from that in liquid. So these are just the major 2 points you can state. Now, state 2 ways in which boiling differ from evaporation. So there are 2 major ways. 1, boiling occur at a fixed temperature called the boiling point, and until the temperature gets to the boiling point, water cannot convert to steam. The liquid cannot change to gas. But evaporation takes place even before the boiling point. It takes place at every temperature. Why? Boiling take place throughout the liquid. Evaporation only happens at the surface of the liquid. So these are the 2 differences between boiling and evaporation. So with this, we have gotten a 2 mark, here, that is 4 marks. Alright, the water is replaced with 200 cm cube of milk. The initial temperature of the milk is 20 degrees Celsius. The boiling point of milk is 95 degrees Celsius. So the temperature increased or rose from 20 degree to 95 before the boiling took place. The milk starts to boil when 6,700 joule of thermal energy has been transferred to it. The density of milk is 1.03 gram per cm cube. Calculate the value of the specific heat capacity of milk. Give your answer to 3 single figure. So to do that, the specific capacity, the energy required, is mass multiplied by specific capacity multiplied by temperature rise. So if you substitute, so we have, since we are given the density, we are given the volume, and we are given the density, so from there we can find the mass. So with that, so the density multiplied by the volume will give us the mass, and then we are looking for specific capacity, which is C. So you rearrange, temperature rise 75. So that gives us the specific capacity of 3,928.8 joule per kilogram per degree Celsius.
You are a brilliant student who wants to succeed. Please subscribe so that you keep up to date, because more tutorials solving past exam questions to assist you will be uploaded.